Hey everyone, Mr. Voikin here. We're moving on to Unit 8, Lesson 1, and we're going to be taking a look at linear relations. So we're just basically going to be looking at lines and different aspects of those lines and doing some calculations with them. So in the previous unit, we were actually dealing a lot with some lines. Now, what we're used to seeing is a line going, say, in this case, from right to left with a couple arrows indicating that it goes infinitely in the positive direction and infinitely in the negative direction in a horizontal direction. Okay, so these are horizontal lines, the ones that are laying sort of flat, parallel to the x-axis. Now, this is not very practical in most situations. A lot of things have restrictions, and that is sort of what we have when we talk about domain and range. So what is the minimum and what is sort of the maximum x values in this case? So it would usually be like, it's not going to go infinitely to the left. We're going to stop right there at -3, and it's not going to go infinitely to the right. We're going to stop right there at +7. And that looks exactly like this line up here going from C to D. And that is called line segment CD. So essentially it starts off as a line going infinitely, but we restrict it to those values right there. Now, if we look at line segment CD and we actually count how many sort of lines there are between those 2 points, we're starting right here and we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that has gone 10 units. Now, we can sort of count things out like that, but that would be sort of ridiculous to do that. I can see that line segment AB is going to be 6 units and line segment EF is going to be 7 units if I just count them out. But the better thing to do is actually figure out the x and y coordinates of these points and then do a little bit of math. Because if these points were some real number values with decimals such as 7.3 and -8.6, we can't just count spaces. Okay, now one thing you need to know about a horizontal line segment or a horizontal line is that they will have the same y values. So when we look at line segment AB, the line segment going between point A, which is right here, and point B, which is right there, what is the y value? Well, the y value in both those cases is going to be 8. Okay, and the same thing would go for the other 3 points. The y values are going to be the same for this horizontal line and that horizontal line. So the line segment going between C and D is going to have a y value of 4 on both points, on every point. And the line segment EF is going to have a y value of -6. But it's not the y value that we're going to be using to calculate the length of the line. The y, having the same y values tells me that, yes, it is a horizontal line. But now I'm going to use those x values in order to find the length of the line. So when I look at point A, the x value is going to be 2. And when I look at point B, the x value is going to be 8. And so when we look down below in part C, it says xb. That means what is the x at B? It's 8 minus the x at A, which is 2, giving us 6, the same as we had above. So what is the x value at C? Well, it's going to be -3. What is the x value at D? It looks like 7. So basically what we're getting is the larger value usually goes first. So it'll be 7 minus -3. Now, we know that if we have 2 minuses together, that's going to form a plus. So really that's 7 plus 3, which gives us 10. And the EF, Looks like it's starting off here at a -9 and it's finishing off at a subtracting, and we got -2. Okay, now in this case, if we look at this, it's going to be -9 plus 2. So what I actually did in this case is I started off with, I did it sort of backwards. I started off with a smaller point first, okay? But we can do that. So if I have -9 minus -2, remember these two negatives are going to make a plus. But if I do the math as is, it's going to equal -9 plus 2 is going to be a -7. But we know that the length of anything cannot be negative. All dimensions have to be positive. So what we do is we take the absolute value of that, which means whatever is between those two green lines becomes positive. So this case, what we're actually doing is finding the absolute value of -9 minus -2, which equals the absolute value of -7, which is just the positive value of that. So it equals +7. So this is a 7 right there. Okay. As I said, normally we would try to put the larger number minus the smaller number. Okay, and going to part D, I think that's what it's sort of asking. How can the coordinates of the endpoints of a horizontal line segment be used to find the length of the line segment? Well, first of all, if it's horizontal, we already discussed that it will have the same y points. And what are we going to do to determine its length? We're going to take the x value that is largest, and we're going to subtract the x value that is smallest, and really we're taking the absolute value of that to equal the length. And that's basically because if I did it backwards for some reason, if I didn't know which one was the smaller value or the larger value, I'm basically going to take x1, or we could call it the second point, x2 minus x1, take the absolute value of that to equal the length of the line. Okay. All right, so let's take a look at class example 1. It says I have a line segment called AB. Now we don't have a graph in this case. I just know it's going to be a line going between a point that's labeled as A and a point that's labeled as B. So first things you need to do is look at, there's an 8, both in the Y position. This is going to be a horizontal line that's going between points A and points B. So again, we can take the larger of the two values, which is going to be the 2, and we're going to subtract the smaller of the two values, which is the -5. And of course, we want the absolute value of that. The negative is going to make a positive, and 2 plus 5 equals 7. So the length of AB, and you can see right here, they're just going AB and putting a little line above that. So that's what that, whenever you see this line AB, it's basically saying that is line AB. Okay, determine the length of a line segment from point P to point Q. Now again, what I want to do is take a look and see, is this a horizontal line? So I'm going to look at the Y value and the Y value. And they're both, in this case, B. So it's a variable, not a number, but they're both B, so they are the same, indicating that it is a horizontal line going between point P and finishing off at point Q. Okay, now again, I don't know which one's the larger one and which one's the smaller one, but I know that one of the values is actually A minus 2 and the other one is A plus 4. So we just have to remember, what did we do? We just took one value, subtracted the other value, and used the absolute value of that. Okay, so in this case, I'm going to be like, what is the absolute value of a minus 2, that is point P, minus a plus 4, and that's going to equal the length. Okay, now this is going back a couple of units. Because of this minus sign that's in the middle here, I have to change the signs of everything within that binomial. So this is going to be a minus 2 minus a minus 4, and I want the absolute value of that. Okay, and now what we have is a and an a. So an a and a negative a. So those are just going to cancel each other out. And I'm left with a negative 2 and a negative 4. So basically I've got the absolute value of negative 2 plus negative 4 is negative 6. The absolute value of negative 6 is 6. So the length of this line is 6 units long. If they actually gave us the units, we would want to indicate those units as well. Okay, so this section right here is just dealing with vertical lines. So vertical line, the concept is going to be exactly the same as the horizontal line, except you should be able to realize that instead of having the same y value, you're going to have the same x values. And we have a line segment going between 2 points. So when I look at the line segment GH, I can see that the x value in G and H, they're both at negative 3. And the x value in IJ, they're both at positive 1. And the x value on LK or KL, you could say it either way, is going to be a positive 6. So again, that same x value is just used to tell me that it is going to be a vertical line. Okay, and that's going to be parallel to the y-axis. So what is the length of GH? Well, again, I don't want to start counting all these lines, so I'm just going to jump right down to this section C right here, where I can use the coordinates. So we need to find the coordinates of point G, and that's going to be negative 6, 7, 8 on G, and on H it's going to be a positive 4. And so basically we're going to go 4 minus negative 8, which is going to give us 12. Okay, and on point I, or line IJ, point I, the y value is 2, and on J the y value is 7, and it's just going to be 7 minus 2, which gives me a length of 5. And on KL, point K is at negative 8, point L is at negative 2. Negative 2 is larger, so negative 2 minus negative 8 is going to give us negative 2 plus 8, which is going to give us a length of 6. Okay, and how can we determine the coordinates of the endpoints of a line segment that is vertical? Well, first of all, in order to know that it is a vertical line, we figure out that it has the same x value. And then what are we going to do? Well, we're going to take the absolute value of the y large minus the y small, and that is going to give us the length of that line. And again, if I did it backwards, it's going to work out because we're doing the absolute value. So really what we're looking at is a y2 minus y1. The absolute value of that is going to give us the length of that line. Okay, taking a look at class example 2, we have a line segment called RS, and we note that it's got the same x values. That means that it is a vertical line going between 2 points that we're calling R and S in this case. And all I want to do is take the absolute value of the larger number, which is going to be -4. And I'm going to subtract from that -9. And don't forget, I'm taking the absolute value of that. And two negatives make a positive. So I've got -4 plus 9, which is going to equal 5 units. Okay, and again, if we look at part B, it's just telling us we have a line segment. And if I look at the x values, they're both a in this case, so we know they're the same. So I have a vertical line again going between 2 points. One is called P, one is called Q. I don't really know in this case which one is larger or smaller. So I'm just going to basically take the absolute value of, I'll just go P minus Q. So point P is going to be the y value, and point P is B. And from that, I'm going to subtract B plus 10. So it's best to put this in brackets right here. And the absolute value of that. Because don't forget, we're going to be subtracting B, subtracting 10. So if I was to rewrite this, it would be the absolute value of B minus 10. So in this case, the B's are going to cancel each other out, and I'm going to end up with the absolute value of -10, and the absolute value of any number is just the positive value of that number, so it's 10 units. All right, so far we have been looking at horizontal lines, which is parallel to the x, going from right to left, or left to right in this case. And what do we know about that line? But they're going to have the same y values, which means to determine its length, we're going to subtract the x values. And then with vertical lines, we're going from that point up to that point with a straight line. And what do we know about a vertical line? Well, it is going to have the same x values. So to figure out the length of the line, we're just going to subtract the y values. Now, what about a line that is not horizontal or vertical? So in this case, we're going to be forming this right angle triangle, and that angled line would be the hypotenuse. So we know from previous units that to figure out the length of the hypotenuse, that is this right here, which is the c. And so we basically have a squared plus b squared equals c squared. And a lot of times it is written as c squared equals a squared plus b squared. Same thing, just in reverse. So if I want to figure out the length of that line, I now need to figure out the length of A, and the length of B, and once I have that, I can determine the length of C. This has a squared right there. Okay, so let's take a look at example 3, and that's what we have. If we look at line segment AB, it is neither a horizontal line or a vertical line, but I can form a right angle triangle by going from point B in the horizontal direction and going from point A down in the vertical direction. So I now have a right angle triangle. So I now need to determine the length of B. So we'll call this little one down here B, and we'll call the other one over here A, and we're going to be calculating C. So let's move this up a little bit. Okay, so what is the length of B? Well, again, we can count those squares, but you don't want to get used to counting. You want to be able to do the math. Even if it's simple math, you just want to do the math, so when it's more complex, you have that process down pat. So the length of B is going to equal the absolute value of one point versus subtracting the other point. So when we look here, if I move over, it's going to be at -5 is the larger point. So it's going to be -5 minus -9. And again, we're taking the absolute value of that, a negative and a negative together, make a positive. This is going to equal, again, the absolute value of -5 plus 9, which is 4, and the absolute value of 4 is 4. So the length of B is 4 units. Now to figure out what we're calling line A, that is going to equal the absolute value of, well, again, our largest point, which is going to be up at the A right there, which is 7. We're going to subtract from that the smaller point, which happens to be -3. And don't forget, we're taking the absolute value, and two negatives make a positive. So I've got this equaling the absolute value of 7 plus 3, which is 10, and the absolute value is 10. So for A line segment that we're calling A right here, that is going to be 10 units. Now that I know those two, I can figure out the length of that angled line, or that sloped line that we're calling C, or the hypotenuse, just by saying the C squared is going to equal my A squared, which is 10 squared, plus my B squared, which is 4 squared. C squared is going to equal 100 plus 16. C squared is going to equal 116. I'm just going to move over here and up to there. And basically, we take the square root of both those sides right there, and I'm going to end up with C equals the square root of 116. Now, you're either going to be asked to present this in its simplified form as an exact value or as a rounded decimal value. So, if I just take the square root of 116, I end up with, if I round it to 2 decimal places, it's going to be 10.77. But what if I want the exact value? Well, again, this is almost going back to, I think, our first or second unit that we worked on. I know that I can pull a 4 out of this. So the square root of 116 is the same as the square root of 4 times the square root of 29. And because I know that 29 is a prime number, I can stop right there. But this square root of 4, we know that that's a perfect square, so that equals 2. And I still have a root 29, so the exact value is going to be 2 root 29. This one up right here, that is not an exact value. That is going to be what we call an approximate value, and we usually do the equal sign sort of like curved like that. So it approximately equals 10.77 as it's been rounded to the hundredth, but the exact value is 2 root 29, and again, I would be putting down units after both of these, and we're done. Okay, so you would basically do the exact same thing for line segment CD. If you understand what I'm doing right here, I would just move right into the assignment. Otherwise, if you want to see another example, I'm going to sort of erase the work that I've done here and redo this again for line segment CD. Okay, looking at line segment CD, going between those 2 points right there, it is not a horizontal line or a vertical line, so I need to form a right angle triangle with a vertical line coming down, and I'm going to do that again with a little bit thicker of a line so we can see it, a vertical line coming down and a horizontal line going over. That's forming a right angle triangle. And now what I need to do is just label one point as A, another point as B, and we're trying to solve for C. So let's figure out the length of line A, and that is going to be the most positive x value minus the more negative x value, which is going to be the absolute value of 8 minus, looks like 4. So that equals the absolute value of 4, and the absolute value of 4 is 4. So line A is 4 units long. And if we're looking at what we're calling line B in this case, that is going to equal the absolute value of the most positive value, which is 6, minus the more negative one, which actually happens to be a negative value of -2. And we're taking the absolute value of that, realizing two negatives make a positive, and this equals the absolute value of 8, and the absolute value of 8 is 8, so we have B is 8 units long. Now I just need to go C squared equals A squared plus B squared, so C squared equals A, which is 4 squared plus 8 squared. C is going to equal the square root of 16 plus 64, and again bring that up to here. C equals the square root of 80. Okay, again, we're not quite finished here because we want to see if we can we want to be able to put this into its exact value as well as an approximate value. So first of all, let's deal with the approximate value. Okay, and if I punch that into my calculator, the square root of 80 is going to give me approximately 8.94. And that would be units. Okay, and if we're going to take a look at putting it into its exact value, I want to start pulling something out of here. So I realize I can pull out a root 4, and I'm left with a root 20. Now I look at root 20, it's not a prime number, and can I pull a perfect square out of there? Yes, because 4 times 5 is 20, and 4 is a perfect square, so I can pull out another root 4. So really what I've got is root 4 times root 4 times root 5. Now root 4 is 2 times 2 times root 5, and 2 times 2 is 4. I'm left with root 5, and that would be units. And if you want to check that if you're right, now I would just go into my calculator again, and I would type in 4 root 5, hit enter, and I get 8.94. So I've basically verified that my work is correct here by comparing it to this number up there. Hope this helps.